All right, so the video inside of Hawks is good. So the video I'm talking about is this guy right here, where she goes through, oops, wrong button, where she talks about, you know, applying the Chebyshev's theorem. And this is a great explanation, but her magical ability here to, oh, you just take these theorems and subtract them, it doesn't really apply directly with what we're doing inside a class with our empirical rule. So what I'm going to do is I'm going to take an angle here to explain from the empirical rule concept and how we lay out our standard deviations to help you understand. The first thing to remember is that, sorry about that. The first thing to remember is that K, let me get the right tool, K is equal to the number of standard deviations. All right, and so our formula for Chebyshev is 1 minus 1 over K squared. All right, so that's where we're eventually going to go with this, is to this situation right here. But to understand what these numbers do for us, we need to kind of work our way through. So in the spirit of looking at this in the terms of as far as like the way the empirical rule works, and that we start off and we draw our little line here. We take this line, we split it in half, and that number right smack in the middle is going to be our mean. And so in this particular case, from our situation here, our mean is equal to 34,200. And then from there, we go and we take this thing, we split it into standard deviations. So 1 standard deviation, 2 standard deviations, 3 standard deviations above. So that's +1, that's +2, that's +3. We go down, that'd be -1, that would be -2 standard deviations, and -3 standard deviations. So I'm going to come in here and I'm going to use the Greek symbol for population standard deviation behind that. So those are standard deviations above and below the mean. So that's my K value. So these numbers right here are going to correspond to the K value that I'm going to use. So what I need to establish is that I have these numbers. I have this 27,600 and this 40,800, and I need to figure out how many standard deviations those numbers are from the mean. Well, I know that 1 standard deviation is, oops, excuse me, I was thinking about a different question. 1 standard deviation is 2,200. So to find the first standard deviation above, let me get my calculator out here and put this away and kind of get a few things switched around here. View always in front. So if I start off with my mean, I say 34,200, and I add 2,200 to it. So that right there, that number represents 1 standard deviation above, because I've taken and I've added 2,200 onto my mean. So I added it on and I got my new value, my first standard deviation. I do it again. So I add 2,200 on. That's 1 standard deviation. So I say plus 2,200. And I find out that my next landmark, or 2 standard deviations above, is 38,600. I do it again. I add another 2,200. I add another standard deviation on. So plus 2,200. And I come out with, and look, there's one of my numbers. So there's my 40,800 right there. So that's one of my landmarks, and that number is 3. So I'm 3 standard deviations above the mean. So now I need to figure out where this 27 is. Where it is it 1, 2, or 3 standard deviations? Now, just hypothetically, it should be 3, because it should be symmetrical. So we start off, we go back to our mean. So we plug in our mean again, 34,200. But this time, as we're going down, we subtract 2,200. So we subtract 2,200, and that puts us at 32,000. We subtract 2,200, and that puts us at negative, oops, sorry about that. Let's go back up here and fix this. Go right there. So 32,000 minus 2,200. And so that gives me 29. I gotta move some stuff around real quick because my little clerical error there. Erase that. So that puts me at, I subtract 2200. So I go from here, I subtract 2200. That brings me out this value right here, which is 29,800. And I go one more time because I'm not quite there. I'm getting close though. And I subtract 2200, and I get 27,600. And that was after I subtracted another standard deviation. I went down another 2200. So here's my landmarks between those and those. Remember, that's my K value. So what that means here is that what I'm saying is that my K for this particular problem is K equals 3. These data values are 3 standard deviations away from the mean. So what Chebyshev does is it's a quick way to calculate the percentage or the approximate percentage when your data is not necessarily normal. So this isn't as good as the empirical rule. This isn't as good as the standard normal distribution. But this is a quick and dirty way to doing this when we don't necessarily know that our data is normal. And notice here it doesn't say anything about being normal. So now we take our K equals 3, we plug it in, and we got 1 minus 1 over 3 squared. We pull up our calculator again. We plug this in our calculator. So a couple different ways you can plug it in. You can do your 1 divided by your 3 squared. Get the decimal part, and then you can say 1 minus, and you can grab that previous answer. And so that's when that comes out of there, that's where I get that 0.888888 repeating. I'll tell you what to do with that. Another way, just to address the calculator thing real quickly, is another way of plugging this calculator is if you're using a TI-84, you can plug the whole thing in at one time. So you can say 1 minus 1 divided by 3, the second power. And your calculator is smart enough. It knows, please excuse my dear Aunt Sally, if you remember from your algebra classes, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. So it will do the exponent first, then it'll do the division, and then it'll do the subtraction, and still give us that same answer. All right, so now you say to yourself, well, Fix, the answer is 88.89 or something like that percent. Okay, so what the deal is that now we got to take this and multiply. So now we got to change this decimal. We got to multiply it by 100%. So we take this number and we multiply it by 100, and we get 88.8 repeating forever, right? Percent, because now I've converted it to a percent. Now remember, Hawks, I believe their rounding technique is that you always round one more decimal place than the numbers you're working with. So in that particular case here, that means our answer is going to be 88.9%. You're going to take that 8 right there, and that 8 is going to make this 8 round up. And that's where we get our 88.9 using Chebyshev. So I explained the problem all the way through, but the meat and potatoes here was this guy. This is the piece here, so you can understand what she was talking about in her video of why she was subtracting and dividing to figure out how many standard deviations. She was using what's called the z-score, and we'll get more into that as we get going. And what the z-score is where you take the x value that you're looking at minus the mean, and then you divide by the standard deviation. That's essentially what she's doing, and that's called the z-score. So hopefully this will help you kind of put the two things together and kind of form an understanding. Email me questions.